This is a response to Professor Anton's video, Does the Universe Have a Right Side Up? In a nutshell, no it doesn't. Some of what I'm about to say is so obvious, but bear with me. Whenever we look at something, or take a photo, make a film, or draw a diagram, we assume that up is pointing towards the ceiling or the sky, if you're outside, and that down is pointing towards the floor, and ultimately the centre of the Earth. First of all, the Earth is a large spherical object to which we are attached by gravity. It takes a huge amount of effort and energy to get ourselves away from it. This gravity always pulls us towards the centre of the planet, and if it weren't for the ground, the surface, and the fact that the Earth is made of solid matter, we would fall all the way to the centre of gravity. So up for someone in Spain is pointing almost exactly in the opposite direction to someone in New Zealand. And as the Earth spins on its axis once every 24 hours, so does up from our moving frame of reference. Second of all, the Earth is orbiting the Sun, a huge object, 93 million miles away, taking 1 year to travel all the way round. Thirdly, the Sun itself, a very average star, takes about 220 million years to orbit the centre of the galaxy, which itself is composed of about 200 billion other stars. And fourthly, our galaxy is one of billions in the known universe, most of which is expanding, not from a central point, but clusters and superclusters of galaxies are all moving away from each other. It just so happens that what we call north is usually up on maps and globes, but humans could just as easily have chosen south as up. Maps would still make sense, but apart from a few upside-down road maps, it keeps things simple by having north at the top of the page. As far as the Big Dipper is concerned, saying that it only looks like it does from this planet is something of an understatement. The Big Dipper would look the same to us from anywhere in our solar system, from the Sun to Neptune and beyond, into the realm of the comets, the Kuiper Belt. Interstellar distances are so vast that to say our closest neighbouring star, Alpha Centauri, is just over 4 light years away means that it takes 4.2 years for its light to reach us. Light travels at 186,000 miles per second, which means Alpha Centauri is about 24 trillion miles from us. And that is the closest star. Most of the brightest stars we see in the night sky, including all those in the Big Dipper, are within a few hundred light years. Our galaxy is 100,000 light years across, and we are about 26,000 light years from the centre. So if we could travel to other local stars, which we can't with present technology, the patterns of the constellations would be different, because the individual stars we see in the recognisable patterns are at different distances from us. There is no right side up, because there is no fixed point of reference. Everything in the universe is moving relative to everything else, and as far as we can tell, the universe is similar in all directions. The closest approximation we could imagine would be a 3-dimensional grid expanding with the universe, but it is easiest to abandon the concept of a fixed position and accept that everything is relative and on a local level focus our attention on the Earth.